welcome. Hi, guys. How's everyone doing? Nice to see you. Nice to see you. Welcome. We have a lot going on here today, as you can see. Welcome to Cool Jobs. How many of you have been to Cool Jobs before? All right, so you guys know what you're in for. So basically, the idea here is that we find some people that have really, well, cool jobs, and that they use science and technology to help them do their jobs. And I see we got a lot of young people in our audience, so maybe we can give you guys some ideas of jobs that you might want to do as you guys go through your education. We have a lot that was going on. The studio's been very busy today. See, like already, I don't even know what this thing, I don't think that should be there. Hey, guys, Mark over, lighting director, I'm pretty sure that shouldn't be there. Can we get that moved out of the way before we get started? Sorry, we're just a few last minute deets. Thank you very much. Can you guess? Just be careful. You might want to move that a little closer.
No problem.
No,
Which way you need that pointed over here?
You don't want to reach.
Over there?
No, I don't want you. Ladies and gentlemen, won't you welcome special effects master and stunt coordinator Steve Wolf.
How are you? Hi, my name is Steve Wolf.
And I'm Dashna Wolf.
And our family has been doing stunts and special effects for about 27 years.
My dad has thrown people off roofs, crashed cars, lit people on fire, and blown up buildings.
So we have every opportunity to get hurt. We work with a lot of science, though.
And safety.
And safety, too. Thanks. I always forget that. So I want to show you how we blow up people in movies. You guys seen stuff where, like, someone's defusing the bomb, and then the bomb goes off, and they get blown away? So, Dash, look, I want you to defuse that one right there, okay?
Okay.
And CJ, will you help me with this? Because I need more mass than I've got. Ready? Fire in the hole. 3, 2, 1. Wow! Nice. I like that. That was fun. So, this is that right? That was simple pulleys and pendulums. You're a good stuntman, son. You can take that off. So I get to do a lot of fun stuff on movie sets, right? Like my son told you, I crash cars and I blow up people and throw people off roofs. So we want to make sure we take really good care of ourselves and be ready to go to work every day, not miss any work. If the movie star misses work because he's sick, what's the rest of the crew supposed to do? Especially if he's, in every scene, big expensive problem. So we had to make sure that we, eat right, take good care of our bodies, drink a lot of water, get some exercise once in a while. And then when we're working with chemicals and making fires, we need to apply the same safety standards, right? You guys like fire? Okay, good. So I'm going to show you what happens. Okay, what I do is I make it out of fuel, okay, which is anything that burns. And then I need oxygen, which I borrow from this room. I won't take too much of it. And then I need to have heat, and I have to have a chemical reaction. All right, now before I expose you guys to these chemicals, of course, we always want to follow chemical safety, right? So we're going to release this stuff in the air. We want to know if it's safe for us. I developed this rule for chemical safety called the 5-in rule. The 5-in rule says if you're going to be in contact with something, touching it, right? If you're going to be inhaling something, ingesting something, or injecting something, then you have to read the instructions, all right? That's the only way to know. And it says right here, the contents of this vessel are safe for human inhalation. What does that mean? Safe to breathe, right. Long-term exposure may cause hair loss. I don't believe that. Come on. Let me see. All right, that seems to be working. All right, so I'm going to get a little bit of fuel. This is a fuel called propane, by the way. It's a hydrocarbon fuel. It's made out of which two elements? You guys are good. I was going to trick you. I thought this is zinc and selenium, but it's hydrogen and carbon. So we bring our fire into here, and now we've got our house on fire, because when we're making a house on fire in the movies, we don't use real houses because real house will burn down in about 20 minutes. We have to have a house that can stay on fire for as long as we need it to. If we're not filming over here, we don't need fire there, right? If this is like the twins jump out of the window over here, so we could just tell this fire, you can go over here too. Excuse me, yeah, I'm talking to you. Thank you. I need you over here. Good, thank you. Excellent. All right, good. This is what we want you to do, but this is just rehearsal. I need you to just wait. I need you to wait back in the bottle now. Yeah, you'll get to come out again in a minute. Thanks. Good. All right, you guys know I'm just messing around, right? You can't tell fire where to go. As much as I thought that you could when I was 6, but really what we're doing here is we were just playing around with these valves back here. So by opening and closing valves, we can control where the fire goes on a movie set. You guys know what a valve is, right? It's a simple mechanical device that controls the flow of a fluid. You know what fluids are? Yeah, okay, I'll give you a hint. 2 out of the 3 states of matter are fluids, and solids are not one of them. Liquids and gas, right? Anything that takes the shape of the container you put it in is oh, excuse me a second, hang on. Didn't realize I had my house so dirty here. Let me just clean that up for you. All right, there we go. Ugh. Look at that, it looks like my kid's room after a play date, huh? You know what this is? This is actually evidence that we had a chemical reaction here. This stuff is something we just made today. It wasn't there before, because the crew did a great job cleaning this thing up to make sure it looked nice for you. This stuff called carbon. You know what this can do to you? Who says kill you? Absolutely right. 10,000 pounds of carbon falls on your head, boom, you're dead, just like that. Other than that, this stuff won't hurt you at all, maybe just get you a little bit of dirty. And there is actually a dirty little secret about carbon, and that's that you're made out of it. It's not just you, okay? It's your parents and teachers and everything that you eat, every living thing on this planet made out of carbon. Now, why do we set houses on fire in movies? Looks cool, right? But the thing is, you couldn't have a whole movie just about a house on fire. You have to have somebody stuck in the house. Maybe they're hiding up on the roof, and then they're trying to get away from the fire, and they're trying to figure, how are they going to not get eaten up as the fire burns through the roof? What are they going to do? You're going to have to jump off the roof. Now, there's a secret to jumping off roofs, okay? The secret is it doesn't matter if the roof is 1 foot high, the roof is 500 feet high. All that the stunt person has to do, I'm going to show you, all that they have to do is take one step, and what does the work of getting them to the ground? Shh, that's my secret. I go to work, I take one step, gravity does all the work, but I get to keep all the money. It's a pretty good deal, right? Is there anyone who wouldn't want a job like that? Go to work, take one step, your job's done. Get your money, go home. No? Why not? You think that's dangerous? Okay. Some people think it's dangerous. 27 years of stunt work, I really can't remember one time I ever saw anyone get hurt falling. I've seen some people get killed landing. That's a completely different part of the stunt, though, right? So when we land, we make sure we have something nice and soft underneath us. We use air, because air is a gas, and gases are compressible. You can squeeze them, and they give you a nice, soft, safe landing. Then we just have to figure out how to get back up again so we can jump again, because, it's not daredevil work, it's science. I'm an engineer, and we have to figure out how these things get done safely. So when we want to get back to the top of a tall building, we use this technology called an elevator. But if we're filming in the jungle, we have to get up on top of a cliff or pull someone up from a deep crevice in the ground, then we have to have some simple machines that we could bring with us and set up anywhere. So there's 6 different types of simple machines. What are they? You have wheels and axles, levers, wedges, screws, inclined planes, and pulleys have always been my favorite. I'm going to show you why. I've got a bunch of pulleys here. And when I was in 4th grade, my teacher drew on the blackboard, and she said that using pulleys, you could lift things that are heavier than you are. I'm going to need to borrow you for a second, Bob. Yeah.
They told me all the cool kids wear these now.
Bob, you come out here in front of all these people wearing this funny underwear? No, Bob's actually wearing a professional harness, just like the one that I had access to when I was in 4th grade.
Oh, nice.
When I went in my house to see if my teacher was right, when she said I could lift things that are heavier than I was if I had pulleys. So I hooked up some pulleys in my backyard, and I ran in my house looking for something heavy to lift, and the first thing I found was my mom. And she was a great sport. She let me actually hook her up to this thing and lift her up. Thank you, Mom. Appreciate it.
Wait, how high up are we
my
going?
mom right here, by the way.
Mom here?
So I need some who are my trained guys? We're going to see if these things actually work, all right? Now, let me explain how this thing works. One pulley just changes the direction of the force of a rope, all right? But if you use more than one pulley, it divides the load, and I don't mean that in a pejorative way, okay? It divides, a load is a physics term for something that's being lifted. So it divides the load by the number of ropes that are holding it up. Okay? So if you want to do the math, just think that pulley stands for pieces of line. How many pieces of line are there that are holding you up? It's taking some liberties on spelling, but in English you can do that.
10?
Gentlemen, come on over here. You guys know the story of Jack and the Beanstalk? The Beanstalk. Jack, come on over here. All right, don't let go, or what happens? The beanstalk shoots up, right?
In your hand.
All right, so we're going to start to press down on here. Hang on, stay right here. Okay, I need you to keep an eye on these guys, make sure they're doing what they're supposed to do, all right? All right, so we're going to start to pull down on that rope. Go ahead. Pull fast. Pull, pull, pull. We're going to see what happens.
Oh, boy.
If we can lift. We want to make sure this stuff is strong, right? Not strong like if you sit on it, it crushes. That's compressive strength. We're looking here for tensile strength, which is you pull on something and it doesn't break. And he seems to so far be going up.
My life is in the hands of middle schoolers.
Oh my, you are in trouble. Whoa, is everything good with that? What do you think, CJ? Yeah, looks good. Whoa. Oh, I did forget something. Darn, I always forget something. I said whenever we have a stunt person in the air, we have to have something nice and soft underneath. There we go. Whew, what's your name?
Marion.
Marion, how are you? How old are you?
13.
Marion, you're 13?
Yeah.
All right, guys, will you hold this for a minute? Let go of the bottom part here. So, Marion, I'm going to be honest with you. Okay? You actually have all the danger right now. You know what this tells me, though? This tells me that you're very brave, you're willing to take some risks, and in the science community, that's going to be a good thing for you. In fact, you'll be rewarded with responsibility. You know what responsibility is? Yeah, it means if you're in charge of something, no matter what happens, it's on your head. All right, so guys, I'm going to have you let go of this for 1 second. We're going to see if Marion can hold Science Bob up by herself. We just want to make sure that we're right underneath him, though, just in case anything goes wrong. And Marion, look at that. So can we take this a step further? I just want to see, can you put your pinky in there? All right, so this is not a blackboard, right? This is real science here. So Marion, what you just proved, actually you just proved two incredibly important physics concepts. Okay? The first thing that you just proved is that using pulleys to multiply your force, a 13-year-old girl is able to hold up a man who weighs enough to preside over an audience of 720 people, which is phenomenal. But you know what else you just proved? Marion, you just proved that a girl with her little pinky could easily do the work of any 4 men. Nice work. Nice job. All right, should we let this guy back down? All right, we're going to let you back down, Bobby. Coming down.
All right.
Here's the runway. Foam up the runway. He's coming in hot. Oh! Ow, what just happened to my hand? Why is it turned friction? That's bad, right? The F word, don't like that. Two things rub together, they create friction. Good. All right, we're going to get you out of this. Thank you so much. Awesome job. You guys were awesome. Thank you. Cool. All right. Parents, thank you guys so much for bringing your kids out here today, because it's your support of their kids' interest in science that allows them to go up and do crazy stuff like I do. Thank you so much. All right.
All right. That is Steve Wolf. Awesome. All right, terrific. All right, we're going to go. Do I just look ridiculous with this big spot now? We're going to go now from the fantasy world of the movies to the wonderful world of the ocean. And, I know, I like that. How many of you have seen that movie, Finding Nemo? Yeah, and there's a new one coming out, Finding Dory's coming out. That's kind of exciting. And I love it when they're going through and there's all those beautiful corals and the little urchins and the little sea anemone, the little things that go like this. Those are really nice. Well, it turns out that those are beautiful, but they're also a little bit in danger. The good news is we have someone who has a very cool job to help and preserve those. So please welcome marine biologist Marah Hardt.
Everyone, how's everyone this afternoon? Good. Well, I'm super excited to be here, and for the next 10 to 15 minutes, we are going to immerse you in the world of what it's like to be a marine biologist. But I warn you, my journey through the oceans has not been totally conventional, so we're not going to stay underwater the entire time, but we will start there. So, I can't tell you when I first fell in love with the ocean. I have just always wanted to be on, in, or under the sea since I was a little kid. That's me, playing in the water. I grew up just up the coast in Connecticut, and that's actually in Long Island Sound, just a couple of years ago. During middle school, I went to camp and spent my summers down in the Florida Keys, where I learned to scuba dive and to snorkel, and where I first fell in love with sharks. In fact, I fell in love with sharks so much that I actually decided to graduate high school early and go spend the second half of my senior year studying them down in the Bahamas, which, for any of you who remember your second half of senior year in high school, I was pretty nerdy, but it was, for me, the better choice. Down there, I also learned a lot about coral reefs, which became my true passion. This is what I studied when I went to college and then on to graduate school. And to study coral reefs, we get to wear funky outfits like this, mask, fins, big tank on your back so you can breathe underwater, called scuba diving. Anybody here do scuba diving? Excellent. Well, since we can't actually teleport ourselves down to a tropical reef in the Caribbean at this moment, we are going to have to use our imaginations and a little bit of sound to set the scene so that we can go dive on our coral reef today. And I'm gonna need your help. So who's ready to help recreate a coral reef? Okay? All right. So we're gonna go section by section of the audience, and I'm going to assign you a different sound that is going to paint the soundscape of a coral reef, because coral reefs are actually really noisy places. The first sound that we hear when we get on our boat to go out to a coral reef is the lovely lapping of the waves. So this part of the ocean, you're going to be my surf sound. Can you all make a shh, 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 shh? Excellent. Okay, hold that sound, hold that sound. The next sound, so we're gonna quiet the surf and we're gonna go underwater. You hear that crackling, crunching? It's the parrotfish. These guys have big beaks that they use to scrape seaweed and keep the coral reef clean. So this part, all the way to the back, you guys can be my parrotfish. So, excellent, good parrotfish. All right, save that sound. Move to the next section. Other fish on the reef. Can you guess what these guys might be called? Grunts, because they grunt. So, right down here in the middle, let's hear your best grunt. Excellent, good, good. Okay, and now, one of my favorite fish on the reef. These are the Goliath groupers. They're one of the biggest reef fish in the world, over 800 pounds. And they make a deep, booming bass, like a doo, doo, doo. So, right down here, you guys can be my Goliath groupers. Let's hear your biggest booming bass sound. Doo, doo. Excellent, good. And then last but not least, some of the smallest animals make the biggest sounds. These are the snapping shrimp. And they make this crackling, popping sound, and if you can't snap, you can use your mouth. Little clicks. Excellent, very good. Okay, so let's practice this again. Over here, let me hear the surf. Shoo, shoo. Excellent, and parrotfish chomping. Grunts, give me some grunts. Big booming bass of the Goliath grouper. Okay, and the snapping shrimp. Okay, we're gonna put this all together now to make our reef, okay? So keep snapping, let's get some surf, parrotfish, grunts, grouper. Close your eyes. There we go, we're on a reef. Let's make it loud. Ah, good. All right, and now let's bring it down. Quieter, 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 quieter. All right. Many of the reefs that I dove on were beautiful, loud places. Some of them were quiet. And a quiet reef is a sign of a sick reef. Some of the reefs I dove on looked more like this. There are lots of problems facing our ocean today, and part of my job as a marine scientist is to study not only what goes right to make a reef healthy, but also what's going wrong so that we can try to fix it. So I spent a lot of my time diving on corals. We lay down long transect tapes, we swim along them, we count the corals, we count the fish, we count the sea urchins, we count the sea algae, and we try to see and look for patterns in what makes a reef healthy and what makes them sick. And this was all fantastic. I got to spend a lot of time out in the water. I got to see a lot of really cool animals. But I also realized that not a lot of people knew what the problems were, right? Because when we look at the ocean, it looks the same. We can't see underwater. So I decided that I needed to start not only studying the reefs, but also talking about what was going wrong. I wanted to be the Lorax for the seas, since the seas have no voice of their own. So I started writing stories about what was going wrong, and then I teamed up with an organization that I work for now called Future of Fish. And we are a bunch of scientists and journalists, people who are experts in business and strategy, and we work together to help innovators and entrepreneurs entrepreneurs are people who run businesses, who are trying to make solutions that help us work with the oceans in a healthier and more sustainable way. There's lots of different ways we do this, but one of the main things that we focus on is overfishing. So has anybody heard of the term overfishing? Yeah, okay, good, right? So that's when we take out too many of the ocean's life and they can't replenish quick enough. So this has happened in our own backyard right here in New York. Did you guys know that there used to be huge oyster reefs in New York Harbor? Who here knew that? Awesome, awesome. So oysters are awesome animals, right? Somebody tell me something cool that an oyster can do. You can eat it. Yeah? Yeah. Definitely, definitely cool. What else? They can make pearls, that's right. The ones right here off of New York, unfortunately, don't make pearls, but most do, yeah? They clean the water, that's right. Thank you very much. So, here we have 2 tanks. This is ocean water from right off the coast here. This was collected yesterday. Oysters were put in, and in one day, this is how well they can clean the water. Yeah, right? One oyster can filter 50 gallons of water a day. So oyster reefs are really, really cool. They're natural water filtration plants. But because they taste so good, over the last 150, 200 years, we've taken most of them out. So this has led to all sorts of problems, and we're trying to fix those problems by now starting to put oysters back in. And some of the groups that I've been working with lately, the Hudson River Foundation, New York, New Jersey Baykeepers, there's all these different organizations out there that are finding new ways to build oyster reefs and put them back into the environment. This brings housing and habitat for fish and crabs and shrimp, cleans the water. So another thing that healthy oyster reefs can do, you guys know what that is? They form underwater walls that act like barriers that can help control storm impacts. You know how bad Hurricane Sandy, they're not going to stop flooding from a big storm like that, but they're definitely going to dampen and lessen it. So getting our oyster reefs back out into the waters is really important for helping to stabilize and secure our coastlines. So oysters are really, really cool. There's also another way that we can get oysters back in the water that we've been working on. That's with a guy who lives up the coast in Connecticut. His name is Bren Smith, and he used to be an oyster commercial fisherman, and he's now turned into an oyster farmer. And he does a new kind of farming called 3D ocean farming, where he hangs ropes down from this array that floats on the surface, and he grows oysters and scallops and clams and seaweeds. And by growing all these things in this new way, he's creating new habitat for fish, he's cleaning the water, and he's producing local food. So in my organization at Future of Fish, I work with my colleagues to try to help folks like Bren, help folks like Baykeeper, to figure out how can we get these ideas to spread? How can we get these innovations to be picked up in more places around the world so that we can start restoring the habitats of the ocean? And the thing that gets me really excited is that the oceans respond very quickly. Oceans are, we call this being very resilient ecosystems. So even though they're facing a lot of threats, when we start to change things, they start to bounce back very, very quickly. One of the things that I get most excited about is how quickly baby fish can come into the oceans and replenish an environment. So, unlike mammals, fish can make lots and lots of babies, as can corals. The abundance is beyond which you could believe. In fact, it's something that's motivated me to write a book that I'm working on now, which is all about where baby fish come from and how much more baby fish we can make in the ocean if we start managing it right. Now, it's hard for me to show you all about baby fish, but baby corals is something that we can go take a look at back out on our reef. So, just to show you how much potential and how much abundance is still out there that we can be fighting for, let's put our masks back on, put on our fins, and we're gonna now go dive back onto the coral reef. But we're gonna do it at night. And we're gonna pretend that it's the third day after the full moon of August. Okay, so about 2 months from now, we can go into the future. And going down right after sunset, we're gonna take our flashlights and peer underwater. And at first, what you're going to see are some bumpy, rocky-looking things. These are the corals. And if you peer really closely at a coral at night on a reef, you'll start to see little animals the size of your thumb, and they hold these tiny little pink spheres. Looks like little tiny balls of candy. You can see them here. These little balls of candy sit in the mouths of the coral all across the reef, and then at exactly 90 minutes after sunset, miles upon miles of reef, something amazing happens. All at once, all at the same time, the reef goes pop. And every single coral releases its bundle, creating this snowstorm These bundles hold the sperm and eggs for the next generation of corals. This is where the baby corals come from, and it pours forth like a blizzard underwater. Except instead of snowflakes, they rise up, and they're bright pink. It's a pretty spectacular event, and it happens every year, nighttime on the reefs. And it's gonna happen this year again. It'll happen the year after that, because despite all of the challenges and all of the threats that are facing the oceans these days, the corals are soldiering on. All of that potential is still there. So we just need to get out there and study it and figure out how we can make more and more coral reefs, how we can make more and more baby fish. And that is what I do now, taking my science and combining it with other folks and their skill sets to come up with new solutions to help us create a future that is full of fish.
Bubbles. I'm sorry, I just really like bubbles. All right, well, that is a very important mission, and some of you guys someday might be involved in helping to save our coral reefs, so that is awesome. All right, so now we are going to go from the depths of the ocean to the vastness of the galaxies and the universe. If you're interested in space, then we got a treat for you. Astrophysicist is a job that you go and try to figure out mysteries like, how did the universe begin? Where can we find black holes? Are we alone out there? And so we have an astrophysicist to tell us about her cool job. Please welcome astrophysicist Amber Straughn.
Where did we come from? How did we get here? Are we alone in the universe? These are the kinds of big questions that we as astrophysicists get to ask in our day-to-day jobs. And that's one of the reasons that being an astrophysicist is such a cool job. We get to think about these huge questions that are bigger than just science questions. These are questions that human beings have been asking for millennia. They're questions that get to the heart of why we as human beings are driven to discover and to explore our surroundings. So one of those big questions is, where did we come from? And people often ask me, how did I get to where I am at NASA today? And it's actually quite a simple story. I grew up in a small rural farming town in Arkansas, and the sky was beautiful and dark. So how many of you have been able to get out of the city, way out into the country, to a sky that's dark enough that you can see the Milky Way? Raise your hand. Okay, a good number of you, which is great. Those of you that have never gotten to experience that, make time for it. Go out, see the universe with your eyes. It's amazing. And that's what got me interested in astronomy from very early on. So as a kid growing up in rural Arkansas, the sky was stunningly beautiful. And those stars call my name. They caused me to ask questions like, how many stars are there? What are they like? What are they made of? And what's beyond what I can see? So as an astronomer, one of our primary tools are telescopes. And as an astronomer, I've been able to use telescopes all across the world. It's one of the good perks of being an astronomer is a lot of the world's biggest telescopes are in beautiful places like Hawaii and Chile. And I've been to these telescopes to observe, which is awesome. But even on the world's highest mountaintops, there's still atmosphere. And what astronomers need to do is get above the atmosphere. And so one of the great things we've been able to do as human beings is put telescopes into space. And of course, that's one of the primary jobs that NASA does. This year, all across the world, people are celebrating the launch of the Hubble Space Telescope 25 years ago. How many of you in the room are younger than 25? A lot of you. So think about that. Hubble has been in space for your entire lives. That's pretty remarkable, right? And for the past quarter century, Hubble has been changing the way that we as scientists think about the universe. It has literally fundamentally changed the way that we understand how the universe works. And that's one of the great things about being an astronomer, is being able to learn about how the universe works. And in addition to the awesome science that Hubble has given us stunning imagery. The infamous Eagle Nebula, shown here, better known as the Pillars of Creation, has shown us how beautiful star formation is. So we know that stars are born inside dust pillars like this. Inside these large pillars of dust, baby stars are being formed inside dusty cocoons. And many of these little stars have planets orbiting around them as well. So after stars live out their lives, they shine forth in these brilliant star clusters. This star cluster here contains some of the hottest, brightest, biggest stars that we know of as astronomers. And by studying images like this, in addition to being beautiful, we're able to learn about how processes in the universe work. So these past two images that I've just shown you, the star cluster and the Pillars of Creation, are both structures within our own Milky Way galaxy, so relatively nearby in a cosmic sense. So our Milky Way galaxy contains a couple of 100 billion stars. That's a lot, right? Milky Way is pretty big. If you could stand on a planet at one end of the Milky Way and shine a flashlight across the entire Milky Way galaxy, it would take about 100,000 years for that light to reach across the galaxy. So the Milky Way is huge. But you all probably know the Milky Way is not our only galaxy. We now know that there are many other galaxies in the universe as well. And as an astronomer, if I had to pick my absolute favorite image that Hubble has ever given us, it would be this next one I'm going to show you. And I'm going to ask to bring the lights down so you can really take it in. So the beauty of this image lies in what you're seeing. So let me tell you what you're seeing. This is the Hubble Ultra Deep Field. In this image, Hubble stared at one tiny piece of sky for many, many days. That's like looking at the universe through a straw. If you held out your pinky finger, you could cover up this tiny little patch of sky. So little bitty piece of sky. And in this tiny patch of sky, Hubble sees 10,000 galaxies. So every point of light that you're seeing there is an individual galaxy filled with billions of stars. So what Hubble has given us is the size of the universe. Thanks to Hubble and other telescopes like it, we now know that there are hundreds of billions of other galaxies. The universe is vast and it's filled with beautiful, mysterious things. So we know that the universe is filled with light, but you don't have to be an astronomer to know that, right? You go outside on a sunny day like today, and it's obvious the universe is filled with light. But the light that your eyes can see, and most of the light that Hubble sees, is only a tiny, tiny part of the whole range of light that exists in the universe. So your eyes are detectors, but you can only see a teeny bit of the light. Okay, the universe is filled with light that's bluer than the bluest light your eyes can see, and filled with light that's redder than the reddest light that your eyes can see. And that light that's redder than your eyes can see is called infrared light. And so my friend and colleague Laura has joined me on stage here, and I'm going to show you all a little bit of what infrared light does. People glow in infrared light. See if we can switch to the video here, and I'm going to prove it to you. Yep, light's coming down, good. So see, there I am. Hi, everybody. So I'm glowing in infrared light because I have a heat signature. So you all are glowing too. So wave at your infrared selves. Good. Oh, you guys are really bright. Good deal. Okay, let's bring the lights back up. And so what you're seeing with the infrared light here, or the infrared camera, is a whole range of infrared light. So the whiter part that you're seeing is hotter. The bluer parts are colder. And at this point, I'm going to need some volunteers from the audience. So I need about 5, and I need one of those 5 to be a girl with long hair that doesn't mind having a hairdryer on her hair. You're going to see where this is going. And then 4 others. All right, so just join me right up here. Cool. All right, come a little closer to me. There we go. Okay, So I told you that using this infrared detector, that white is hotter. So what I'm going to do, I'm going to take your little ponytail here. I'm going to blow dry it, okay? Here we go. So check out how white hot her hair gets. Ah! Oh, you can't see. You'll have to turn around. All right, you want me to blow dry your hair? Can you see it? Pretty cool, huh? All right, so white is hot. And what color is cold? Blue. Okay. So what is cold? Ice is cold, right? So I got some ice here. So I want you guys each to grab a piece of ice. Just one little piece of ice, or a big one, doesn't matter. Just a piece of ice. And now, okay. So let's just hold the ice in your hand. Do this.
Blue. It's like black and blue.
So how about this? Take the ice and draw yourself a mustache or maybe a beard on your face. And can you look at, there you go. Look at, look at the camera. So look at your mustaches.
So cold.
All right. Good job. You guys can put your ice back in here. Here we go. Ice back in here. Good job. Good job, you guys. Let's give them a hand. So the really great thing about infrared light and how this relates to astronomy is that some of the biggest questions in astronomy today will be answered by looking at the universe in infrared light. And at NASA, right now, we are building a telescope like this. So at NASA, I work on the James Webb Space Telescope, which is pictured here. It looks a little strange, right? It doesn't look like a normal telescope that you think of as a tube, and that's because it's different. It will observe the universe in infrared light and help us answer some of the biggest questions in astronomy today. So this telescope is by far the biggest telescope that we've ever put into space. This is a full-scale model of it. This was actually here at the World Science Festival in 2010. Do any of you remember seeing it in Battery Park? Okay, cool. So we had it here, and this, of course, is just a model. It's just steel and plastic, but we are building the real thing at NASA right now. So we're going to launch this telescope in 2018. So almost all of the hardware has already been built. So the next few years are going to consist of putting those pieces together, testing and retesting to make sure it works like it's supposed to once it gets out into space. And then we'll launch it in 2018 on a rocket. Now, this telescope is so big, it's bigger than any rocket that we have to launch it on. So what we have to do is fold it up, and then it unfolds like a transformer once it gets into space. Really cool engineering behind this telescope. And if you want to follow along and watch our progress, and you can even watch a webcam where we're building it, it's on our website. It's jwst.nasa.gov, so James Webb Space Telescope.nasa.gov. So this telescope we're building to answer the biggest questions in astronomy. With this telescope, we will be able to see back in time and see the very first galaxies that were born after the Big Bang, over 13.5 billion years into the past. We'll also learn more about how galaxies formed and evolved over time. We'll be able to use that infrared light to peer inside dust clouds to see how those stars are being born. And then we'll also learn about exoplanets. So exoplanets are planets that are orbiting other stars outside of our solar system. And when we first started thinking about how to build this telescope, we didn't even know there were exoplanets that really existed. But now we know of thousands of exoplanets that have been confirmed. And much of that is thanks to NASA's Kepler telescope that just during the last few years has really revolutionized exoplanet science. And in fact, now we know that planets are common. When I was a kid, we didn't even know of any other exoplanets. But now we know that if you go outside at night and point up to a star, it probably has a planet around it. And that's remarkable. That's a new discovery. And this telescope is going to allow us to study the atmospheres of these planets. So think about what that might mean. With this planet, we might discover a water world. We're going to learn about these exoplanets that are out there in much greater detail with this telescope. So we're really, really excited about what's going on with this telescope at NASA. So building big telescopes like this, we do it by asking these specific questions and building the telescope to answer these very specific science questions. And that's great. That's how science progresses. But for me, one of the most exciting things about being an astronomer is knowing that we will find answers to questions that we haven't even thought to ask yet. There are undoubtedly things out there that we haven't thought of that we'll discover with a big telescope like this. And that's the promise of the universe. The promise of hundreds of billions of galaxies filled with hundreds of billions of stars, countless planets, and untold mysteries waiting to be discovered. Thanks.
Wonderful. Wow. So the theme of this year's World Science Festival is Mind Blown. How many of you just had your minds blown? Whoa, that was crazy. That was crazy. I don't think I will ever look up at the sky in quite the same way. And so I love those Hubble pictures, and now we have a telescope that's going to apparently 100 times more powerful. Woo, I can't wait. All right, so let's go now from the depths of space back down to Earth. And instead of looking at black holes and constellations and supernovas, our last cool job presenter looks at porcupines and snakes and hawks and owls, because it turns out that she is the director of wildlife education at the Hawk Creek Wildlife Center. Please welcome our final specialist, Tanya Lowe.
All right, everybody, thank you for joining us today at the World Science Festival. My name is Tanya, and joining us a little bit later today is going to be Jessica. Now, during this segment, we are going to leave the lights up a little bit, and you'll see why. And Jessica and I are from Hawk Creek Wildlife Center, which is a wildlife center located in East Aurora, New York, which is just south of Buffalo. And I really do have one of the coolest jobs in the universe. So I work with amazing animals. I am a caretaker of about 90 permanent residents. I get to train them. I am also a teacher. I get to take animals out to places like this, into classrooms, scouting programs, and share them with people just like you. I'm also a conservationist that has the amazing ability to help conserve wildlife through breeding and reintroduction programs. And so I have an amazing opportunity every day to help wildlife. And a lot of people ask me how I got started with doing what I'm doing. And it all started for me as a child. My mother always fostered a love of animals. We always had pets. Parents, let me tell you, between horses, dogs, cats, and reptiles, I really didn't have time to get into trouble. All right, so pets taught me responsibility. They taught me how much work it was to work with animals, but also how rewarding it was to build a relationship and a bond with them. And on top of that, my grandparents would often take me to SeaWorld when there was a park in Ohio. And when I was there, I was always fascinated with the bird of prey show. One day, I pointed at a beautiful bald eagle named Liberty, and I told my grandparents, one day I'm going to do that. And as grandparents do, they smiled and said, Tanya, you can do whatever you want when you grow up. Little did they know. So I ended up going to Canisius College and getting my undergrad in psychology with animal behavior and zoo biology, and found Hawk Creek Wildlife Center. One of my adventures with Hawk Creek was going to the World Bird Sanctuary in St. Louis, Missouri. Upon taking a tour with the director, Walter Crawford, I was taken to a yard that had about 6 bald eagles tethered in it, and this one bird kept catching my eye until I asked Walter about that particular bird, and he said her name was Liberty. And I said, was she ever used at the shows in SeaWorld, Ohio? And he said, that's the only bald eagle we had there from the 90s until the park closed. As a shiver went down my back, that bird looked at me right in the face, and I did the only thing I could do. I told her thank you, because it was the exact same bird that I pointed to over a decade earlier with my grandparents. That's when I knew that I was on the right path of doing what I was meant to do. Now, that's how I got started, but you guys want to know what the best part of my job is? I get to work with amazing animals. So we're going to introduce you to some of those. And for our first animal, I am going to need Science Bob. Where'd you go? All right, excellent. Science Bob is going to get an amazing opportunity. I have an awesome chair for you.
Okay.
Okay, it's very comfortable. So this is, wow, okay. Well, Jessica was supposed to clean this morning because our first guest, Chase, slept on it last night.
You want me to sit on
Yeah,
it?
sit on that right there. Yeah, you're good. Yep.
Things we do for science, folks.
Yes, exactly. Oh, that's awesome. It's going to make your lab coat look so much better. All right, now you have a camera with you, Science Bob.
Oh, I do have a camera. All right. Thank you.
Bob, what you're going to do is you're going to focus that camera on my hand.
Okay.
Get a lovely picture of my hand.
Grab
All right, so you are going to have just a few moments to get that once-in-a-lifetime shot right before impact.
Of what?
You're going to find out. So our first guest is going to be coming in from the back, and with a name like Hawk Creek, you can bet that we have hawks. And so this first guy here is Chase. Now, Chase is a Harris's hawk, and this Southwest native, like all other raptors, has sharp talons for catching prey and a sharp curved beak for pulling that prey apart. Unlike other birds, other raptors, he's got long legs for perching on cactus, and he's got a long rudder-like tail to help him fly low to the ground and around objects. So those of you that are in his flight path are going to realize that that means that the lower you duck, the lower he's going to fly. Okay? Now, this bird is also extremely intelligent. They have the intelligence of roughly a 7-year-old child. Those of you with 7-year-olds know how fun that is to work with. Sometimes he outsmarts me, I'm not going to lie. But he is an amazing flyer. And to give you an idea of a Harris hawk's intelligence, if they are out hunting a snake, that's okay, he just dropped a piece of food. He's very neat, he picks up after himself. And so when they're hunting snakes, okay, an owl will swoop down, grab a snake, and hope for the best. A Harris's hawk knows that there is a good chance that something he's going after, a snake he's going after, could be venomous. And so they will end up down on the ground, they'll put their wings in front of them, and they'll walk around the snake. The snake will strike the part of the hawk closest to it, and that means that the snake gets a mouthful of feathers, and the hawk reaches out lightning fast with its foot, grabs the snake behind the head, has a meal, has control of that snake's weapon, and can have a nice tasty meal without a fatal bite. Okay, so they are very intelligent birds, and they are very social. They live in groups of about 7 birds. Thank you very much, Science Bob. I hope you got that shot. All right, so very intelligent birds that live in hunting groups and communicate a lot. Now, Science Bob, don't go too far, because I'm going to need your help to get our volunteers. Okay, so we've got some volunteers that are going to come up for a really amazing opportunity. So look for the ushers to grab you out there. All right, and we have to make sure that we have very brave volunteers.
Come on up, guys. Wave to everyone. All right, come on over here, come on over here. We're just going to get in a line and then face the audience. There we go. Good job, good job. Get in a line.
All right, now, while our volunteers are coming up.
All right, here we go.
Oh, look at all of them. I love it.
All right. Wow. All right, here, go over the end there. Go ahead, going over the end. You're doing great.
Oh, wow, we got a lot. I think we're going to have to do a double row. They're multiplying. All right, I'm going to have all of you step up to about this line here. So all of you move up. Perfect. Perfect. Okay,
right.
now you guys hang tight for a second.
A little more room. Go on over the end.
Now, I would like everyone in the audience to please stand up.
Good.
And I want you to, stretch a little bit. All right, very carefully, without hitting the person next to you, put your arms out to the side. Okay, at this point, anyone that is less than 6 feet tall, carefully fold in your wings and sit back down. If you're 6 feet tall, stay up with your wings out. All right, now, everybody, if you look around at the folks still standing, you guys, you have wings too. Put your wings out. All right, everyone that is still standing, congratulations. You have the wingspan of a turkey vulture, just like Barf. All right, guys, take a seat. Now I'm gonna have all of you lay down on the floor with your feet towards the audience and your head towards the screen.
There you go.
Lay right next to each other. Guys, get as close as you can, okay? So pretend you're best friends at a slumber party. Get nice and close. All right. And I'm going to have you guys actually all try and scoot down this way just a little bit. So inchworm.
Towards the audience.
Inchworm towards the audience. Good job. We've got a lot of you here, so we're going to be real tight on the stage for a second. All right, so this is Barf, and Barf is a turkey vulture, which means he is a scavenger. He eats carrion. Do you guys know what carrion is? Not carry on, carrion. Carrion's dead stuff. Okay, so you guys have to lay down and pretend that you're dead. Don't move. All right, so stay nice and still. And this is Barf. He's a turkey vulture. And these guys are really amazing. They have an incredible sense of smell, one of the only birds in the world to have a well-developed sense of smell. In fact, he can smell rotting meat 8 miles away when he's soaring 1,000 feet up in the air. You go back to Jess there, buddy? Good boy. And so that means that Barf knows everyone in this room that has not showered. I see a couple people that look a little guilty when I said that. But on a serious note here, Barf and I have a very close relationship, and he is a personal favorite of mine for a lot of reasons. One is because he is the first bird that I trained for free flight, for doing demonstrations like this, and so him and I have a long relationship. He came to Hawk Creek in 2004, so we've been working with each other for a really long time, and I'm pretty sure I've learned more from him than he's learned from me. But we've also been traveling and talking about a lot of different things. One is imprinting. You see, Barf is very comfortable with all of these people here because Barf is what we call an imprint. He does not understand that he is a turkey vulture. He was raised by people. So, as far as he's concerned, he's the cool kid at the party and everyone is just looking at him and his magnificence. All right? Which also means that he has decided that I am mom, I am also girlfriend, I have many roles. Because he doesn't understand what he is. The first time he saw a turkey vulture, he was terrified. He was so scared. We were flying out in the field exercising, and he actually saw turkey vultures coming in. He folded up his wings, threw himself to the ground, ran in between my shoes, and threw up. On my shoes. I threw them out. Okay, so we're gonna see if we can get one more pass from Barf here. Nice and low. There we go. All right, now you guys were excellent carcasses. Thank you very much. You guys can head back to your seats. Good boy. And now, as I said, Barf and I do travel all over the place, and we like to talk about how amazing vultures are because they are some of the coolest animals on the planet. Thankfully, vultures in North America are doing very well. But we also like to let people know that vultures over in Africa and in Asia are not. Vultures, most people think that they're kind of ugly and gross. People don't pay a lot of attention to them. It's much easier to get people's attention about big, charismatic animals like elephants and rhinos. But in Africa, vultures are being poisoned on purpose by poachers because of what they eat. They are the cleanup crew. They eat things with botulism, anthrax, E. coli, salmonella, and they don't get sick. They keep our environment clean. So when a poacher goes out and kills a rhino or an elephant or any other animal life, the vultures will start circling the carcass to go down and eat it because that's what they're supposed to do, which draws attention to poaching and the illegal activity. So poachers put out poisoned meat first to get rid of the vultures. In Asia, farmers, in India specifically, farmers will leave their cattle out in the field after they die. These cattle have been treated with a medication that is fatal to vultures. For some reason, when they ingest the meat, it causes renal failure. They lost over 95% of their vulture population, which left their environment and their villages in a lot of trouble. Without the vultures, carcasses were everywhere. Feral dogs took up the slack. Feral dogs were not affected by the medication given to the cattle. They also were not afraid of people. So if they ran out of food, they had no problem going into villages. And they started spreading a seriously fatal disease called rabies. So they learned the hard way how important these animals really are. But people are doing something about that. Scientists are putting out vulture restaurants to help vultures. So they have a healthy food source, and the scientists can monitor the birds, and if they're showing signs of poisoning, they're able to be trapped and taken to rehabilitation centers and helped before they get into the stages of renal failure. So people can make a difference. And if you're interested in animals, I encourage all of you to do a couple of things. 1, study hard in school. 2, take a lot of science classes. 3, get involved just by volunteering at your zoos, at wildlife centers, at animal shelters. It gives you valuable experience for the future if you want a career working with animals, and you can learn a lot about what it takes to really work with them. The last thing I want to encourage you guys to do is on your way home, when you go home, whenever you're going somewhere, keep your eyes to the sky. Look for raptors in your neighborhood and never stop learning, because that is the best part about my job is, yes, I get to work with amazing animals, but every single day, I get to learn something new from or about them, because there's so much to learn. Thank you guys very much. We're going to say goodbye to Barf.
All right. Well, I never thought that I would say this, but let's give it up one more time for Tanya and Barf. All right, awesome. Well, we are going to bring out all of our cool jobs presenters here. If you guys are all right, would you guys mind indulging me in a little experiment that I was working on earlier? Is that okay?
Okay.
All right, cool. All right, thanks.
All right.
Tell you what.
Goggles.
Watch your step. This is very slippery. Why don't we have all of our cool jobs participants come on in here and get yourself some safety goggles. And what I've done is I've got a little mixture of dish soap and food coloring and a little chemical called hydrogen peroxide. Yeah, not the stuff you get at the pharmacy. This is about 10 times stronger. So here's what we're going to have you guys do. I'll do a little countdown. We'll do a 3, 2, 1. Then I'm going to have you pour this little beaker here into this flask. Now that's going to create what we call an exothermic decomposition reaction. Or in 4th grade, we say, it's going to make lots of bubbles. All right? And it's going to do it very quickly because although there's extra oxygen in here, it can't quite be released quickly. So this acts as a catalyst to try to do that. Because one of my cool jobs is as a teacher, and that means that I can make a mess from time to time. So we're going to have you pour that in very carefully because I know it's a little slippery. You're going to step back. All right, are we ready? Go ahead and grab yourself the chemical, and you're going to pour, and then you're going to step back. Here we go. In 3, 2, 1, pour. Step back. Wow! That was a good one.
That was awesome, huh? Wow. That looked great.
All right.
That was way cool.
That's wicked.
Have a great World Science Festival, everyone. Thanks for coming.
Thank you. Ready? Line up for a bow and.